First off, some introductions. Hello, everybody. My name is Josh. I'm a senior solutions architect here at Pulumi, and with me is April Edwards. April, if you'd like to introduce yourself.
I am April Edwards. I'm a senior enterprise advocate at, Microsoft at GitHub, formerly Microsoft. And I specialize in DevOps, infrastructure as code, cloud native stuff. And we're here to do some cool things with Pulumi and Azure and AKS today.
Great. So, before we begin, for the folks in the audience, please do comment in the chat liberally. There is if something's cool, let us know. If you have a question, let us know. That way, we're not just streaming into the void here. It helps us as presenters. There's also a Q&A tab that you can see if you want to ask like a question. You can do it either in the main chat or in the QA. We will do our best to get you an answer. Please do join the Pulumi community Slack. It's an excellent place to learn about Pulumi. There are Pulumi staff members in there. There are very experienced Pulumi users in there and beginners alike. So go there. You can people ask all types of questions in there, from like very, very basic things to like fairly advanced usage scenarios. And the level of engagement there from Pulumi staff and community is really excellent. So can't recommend it highly enough. It's like probably the single best tool to learn Pulumi. There is the full code for this workshop that is in the handouts link on the handouts tab. Your feedback is always welcome. Please let us know what works, what doesn't, and what type of future content you'd like to see, because we want to serve you, our audience. You will get a YouTube link in a follow-up email within a day or two after this workshop. That's a frequent question that comes up. So you don't need to follow along. You don't need to follow on like line by line with anything we're doing. The full code is available, and you will get a link to a video version of this workshop that you can go through at your own pace. Some of the prerequisites for the stuff that we're doing here, you'll need you'll need an Azure account, which you definitely do not find at google.com. That would be at portal.azure.com, I believe.
It is portal.azure.com, yes.
All right. You will need the Pulumi CLI, which you can install. If you go to Pulumi.com, it's pretty easy to find the link for that. You'll need a Pulumi account. You don't strictly need a Pulumi account, but it's easiest when you're learning Pulumi to use the Pulumi Cloud as your back end. That is free for individual use, so there's no Pulumi charges for anything that we're doing today. There will be charges, of course, for the Azure resources that you spin up if they're out of the free tier. I don't know the details on that, but those costs should be like fairly minimal. You will also need Node 19 and TypeScript 4. That may not be the minimum requirement, but I know that particular combination of versions will work. So a little bit about Pulumi. First off, again, do create a Pulumi account. It's free. There's a sign-up link on the handouts tab. What that will do is that will give you state file management and a secrets provider. That will, and it's the easiest way to get started with Pulumi. Once you have used Pulumi, you're getting comfortable with it, and you're thinking about maybe your organization adopting it, that would be a good time to sign up for a free trial. You get 14 days free with no credit card required, and it gives you like our full suite of features, including like SCIM and SSO, organization-wide policy, things like that. So, don't use your trial when you're like just getting spun up. Save it for when you're thinking about adopting at an organizational level, because Pulumi Cloud is totally free for individual use. So you don't get much out of signing up for the trial when you're just using it as a single person. So what is Pulumi? Pulumi is Universal Infrastructure as Code. It's an IAC tool that allows you to use real programming languages with any cloud. Of course, that includes Azure, but we have a large ecosystem of providers that we work with, about 130, I think, at most recent count. So that's all the major public cloud providers, and as well as like SaaS services like Datadog, New Relic, of course, GitHub. We have a GitHub provider that we use internally at Pulumi pretty extensively. You name it, there's probably a Pulumi provider for it. And you can find our complete list of providers in the Pulumi registry, and I will throw a link to that on the handouts shortly. And of course, we also have a Kubernetes provider, which we will be demonstrating today.
Yes.
A little bit about the structure of a Pulumi program. So at the topmost level, you have a project. You don't really deal that much with projects directly. When you initialize a Pulumi program, it creates the project, and you don't really think about it that much afterwards. Within the project, we have the Pulumi program. And the Pulumi program, that's where your code goes. Today, we'll be using TypeScript. So that'll be your index.ts file is where the main entry point is. Within your program, we have resources. An example of a resource, for example, would be an Azure resource group or your AKS cluster. Resources have inputs and outputs. When you create an Azure resource group, for example, one of the inputs is the name. And then resources also have outputs. Those outputs often become the inputs to other resources. So, for example, what we'll be doing today is we'll be creating an AKS cluster. We'll be grabbing the kube config from that as an output, and then that will become the input when we create our Kubernetes manifests. So in addition to the program, we also have stacks. And stacks are instances of the program. So in our AKS use case, we might have a dev, a QA, and a prod stack. And we might, so those stacks are going to generally contain configuration values. So for example, we might want less worker nodes or less powerful worker nodes in our dev stack than we would in our QA or prod environments. So that's the Pulumi program model. A little bit about the physical model. So we have the Pulumi program in the bottom left. You can write Pulumi programs in a range of languages, including Python, TypeScript, which is what we'll be using today. We support Go, we support .NET, so that's actually both C# and F#. And we have Java support in preview, and we also have a YAML option. So your Pulumi program is interacts with the Pulumi engine. The Pulumi engine is the Pulumi CLI. And the engine is going to look at your state file, which is stored. Today, we'll be using Pulumi Cloud as our backend, the Pulumi service. And it looks at your state file. And it also interacts with the Pulumi providers, which you see on the bottom right, to figure out what resources need to be created, updated, or deleted. And so Pulumi works in a declarative fashion. So when you write your Pulumi program, you just say, okay, I want an AKS cluster with these attributes, and the Pulumi engine will interact with your state file to figure out what changes need to be made. You don't need to, in your Pulumi program, specify, I want to change this from this to this. The Pulumi engine will figure out those changes for you. And the way that Pulumi interacts with the various cloud providers is using the Pulumi provider. So in the bottom right hand, you see the Pulumi Azure provider. That is what is going to make the actual API request to the Azure API.
I'm going to ask a question that's out there, or answer a question that's out there. We've had a couple people with stuff. Ram has asked, about looking at the industry that Terraform's heavily utilized with infrastructure as code. Absolutely. Terraform has limitations, has a lot of limitations. First and foremost, the language. So it is learning a new language for everyone involved. It uses the HCL language, whereas Pulumi's using your native coding language that you're familiar with. There's actually, Josh didn't mention this, there's a couple folks out in Europe. I can't remember their first names, but I remember the repo. They were getting Terraform support for Pulumi as well. So they've been working on that as well. So it uses your native language. It also has day zero support for Azure resources, specifically around Azure. Terraform has a way to do it now, but it was not inherently built into Terraform initially. It's still a bit of a limitation. But also, I think one of the biggest benefits of Pulumi, because it uses that inherent language, writing tests for your infrastructure as code is a million times easier. If you've ever written testing tools, or use TerraGrunt with Terraform, it's slow and lethargic. So I've worked on a lot of projects with Terraform where it's testing can be a nightmare. Really long running tests, whereas Pulumi, you can run a lot more tests more frequently in that native language. And that's one of the biggest advantages of it from a kind of a development point of view, if that makes sense. But yeah, I think, and then Roderick's answered exactly, you don't need to learn another language. So that's really helpful for it. And then I'll let Josh continue on, talk about the new Pulumi features that I think are pretty awesome.
Yeah, so now we get to the new and shiny. So there is a link to this in the handouts tab, but we have a new feature called Pulumi AI, which is powered by ChatGPT. If you have not used it, it's people seem to be very, very excited about it in the community. It is I used it in part to write some of the content for this workshop and some upcoming workshops. It's very, very useful. You get a prompt. You ask Pulumi AI to do something for you. So, for example, I said, "Show me how to deploy a Helm chart on my AKS cluster," and it will generate the code for you. It's not perfect, but it's pretty good. And it can really help you get if there isn't a specific example for your use case, because there are a lot of Pulumi providers, there are a lot of resources in those providers, and there are a lot of configuration options within those resources. So it's really it can be a great tool if you're trying to learn. So I definitely recommend folks go check out Pulumi AI if you like it. Please spread the word. Say something on social media. We love getting our community members excited about new stuff.
So one question from Ranganath, and I'm sorry if I didn't pronounce that properly. Does Pulumi support Oracle Cloud?
It does. We have an OCI provider. Pretty much all the major, pretty much all the large and smaller cloud providers are supported. April, if you could throw a link to the Pulumi registry in either the handouts tab or in the chat, that would be awesome. I see we have some more. We have, how is it different from the C# SDK? I assume that's the C# Azure SDK. So I would assume that the Azure SDK is going to work in an imperative way, whereas Pulumi is going to be declarative. So if you're creating resources with the Azure C# SDK, and April, please check me if anything I'm saying is incorrect. But you would have to, if you wanted to spin up a cluster, an AKS cluster, right? You're going to write it with, I want 3 worker nodes. And then if you want to change that to be 1 worker node, you would have to specifically say, hey, remove these 2 worker nodes. Whereas in Pulumi, you would run the Pulumi program with 3 worker nodes. And then if you just change it to 1 in your program, Pulumi will figure out that difference for you. So that's kind of one of the key differences.
Yeah, and I haven't, to be honest, for infrastructure changes, I haven't worked with the C# SDK, honestly. I actually spoke to someone about doing this with PowerShell. It's infrastructure updates where Pulumi really shines. So infrastructure changes or somebody goes in and modifies it, Pulumi's there to kind of right the ship and keep it going.
All right. So April,
I'm going to talk about Azure. Right. So let's talk about Azure. So for those of you out there today, I know we've had questions about some other clouds. How many of you, I actually can't see the poll things to see how many of you have used Azure and AKS. I don't know, Josh, if you can.
Yeah. So it's almost split evenly.
Okay.
Looks like folks have at least used it a little bit. So the majority of the audience has at least used it a little bit.
Okay, cool. So we talk a little bit about Azure, a little bit high level for those of you that may or may not have used AKS. So we're going to talk about the Microsoft Cloud. So yes, I work for GitHub. Yes, Microsoft owns it, but we're completely separate entities still. But we do integrate heavily into each other. So everything we're doing today from within GitHub, I'm going to show a lot of the cool GitHub features that will enable you to deploy this demo and go forward and write better code in general. So they all integrate together pretty well. We have a lot of products in the Microsoft Cloud platform. We've got Dynamics 365, Microsoft 365, which I'm sure many of you use, Teams, etc. We've got Power Platform, which is kind of that low code offering. And then we've got Azure. Pretty much all of our products run on Azure. So some of the stuff I show you today, even though it's a GitHub product, will run on Azure in the back end for the compute. So it's some pretty cool stuff. So we have a pretty good stack of things. And I think the biggest thing that Microsoft and GitHub like to talk about is identity and security. So as a developer or someone who works in operations, security is not really at the forefront of what you want to think about, but it has to be at the forefront of everything we do, because we need to make sure we pick the right tech. Because if we go into a technology without the knowledge and the security behind it, it's going to fail. It's not going to be compliant for our organizations. And compliance is one of the biggest things that we talk about. So we also talk about cloud native a lot. So when we talk about cloud native, it's, cloud native has a definition by the CNCF, a formal definition. I determine cloud native as anything that's kind of divided into a microservice. So breaking down those monoliths that we used to use in our infrastructure into more segmented, easy to manage services, so that we're not impacting the whole system. So in a monolithic system, we make a change, the whole thing goes. When we start working with cloud native, we can change one part of the system. So in this case, when we're deploying our Kubernetes cluster today, we can make changes to networking and not affect our entire infrastructure stack. So there's a lot of advantages to that. So part of being cloud native, there's absolutely a security component that we will talk about. We're going to have a lot of development tools. So I'm going to talk about some Azure Container Registry in a little bit, and we're going to use things like Visual Studio Code and GitHub to write our infrastructure as code. And a big part of this is because of the community. Microsoft is actually the largest contributor to the open source community. So we partner with a lot of projects. We start a lot of projects, and then we help support a lot of it. So Dapper's kind of been one of the biggest ones that we've supported in the kind of in the open space, open source AKS space for a while. But we have a lot of offerings in the cloud native space. But we're going to focus mostly in the box today that says containers and serverless. We're going to talk about AKS, and then we're going to touch a little bit on Azure Container Apps in a little bit, because they're also pretty cool. The elements of orchestration. So where does Kubernetes really shine? It does all these things that we don't necessarily want to do in a traditional infrastructure. So we have things like scheduling, being able to have affinity to our pods and anti-affinity. We need to scale, and that's one of the biggest selling points of Kubernetes. And I believe Josh was saying to me earlier, because he works so much in GCP and AWS, you said AKS as a service scales how much faster, Josh? When it builds? Deployment, sorry.
Yeah. So AKS cluster deployments?
Yeah.
About 3.5 minutes, which is significantly faster than some other managed Kubernetes services you may have used.
Yeah, absolutely. So it's definitely scaled really well. The networking component's really strong on it. I saw someone earlier ask about private VNet, private endpoints and VNet configs. We will talk about some of that, and health monitoring. So when we talk about infrastructure, it's great we can deploy with infrastructure as code, but we need to be able to manage that. We need to fail over. In the traditional data center configuration, we used to talk about kind of a backup and DR plan being a whole other physical data center in another location. I've worked with a lot of customers that have that. Now our failover could be something as simple as changing just one of our location of our infrastructure as code. I've worked with a lot of customers where our failover plan is maybe deploying to North Europe, and then the failover goes to West Europe. It goes to a physical different location in Azure. So that is their DR plan. We no longer have to worry about standing up a whole data center and running it 100% of the time, and be able to organize and coordinate our application upgrades, right? We've all been there where we've had these big monolithic apps that have taken days to upgrade, and we do it once every 6 months and they all break. So those are things we want to avoid going down the road, especially in a cloud native mindset. So in terms of AKS, that is Azure's container service. It is Azure Kubernetes service. It's fully managed as a service. So if you think of the kind of service models where you have infrastructure as a service, platform as a service, it fits under the platform as a service model. So you have the whole managed control plane. You have automated upgrades and patches, cluster scaling and healing, and a lot of cost savings. So we're not going to get into cost today about any of that, but it does run as a fully managed service. But there's some advantages and disadvantages to that, because you still have to do a lot of feeding and watering with AKS. And I think that's a misnomer that a lot of people think about when they think about the cloud, especially developers, like, oh, I can just quickly do this. I can spin this thing up. Yes, but it needs feeding and watering. And there's a massive networking component to AKS, especially around private endpoints and management of that. So then we've also pushed out this thing called Azure Container Apps. These are serverless containers for all your microservices. This has taken away all the overhead management that AKS really brought into the field. So you can scale things a little bit more dynamically, and you can focus on the application first. So we see this massive shift in the industry going from lots of code, lots of infrastructure, to low code, less infrastructure. That's where the platform as a service, software as a service really comes in. It also lowers your security footprint when we start doing these things. You think of a traditional operating system, a traditional virtual machine, you have to patch, you have to manage it, the hypervisor, the networking, all these components. When we start looking at AKS, we have to manage all the pods and the containers and the networking, yes, but we have a lower footprint in which to manage. When we go to Azure Container Apps, there's even less for us to have to manage. So we can just focus on the applications to deliver applications first to our end users. So what can you build with Azure Container Apps? Pretty much a lot of things. You could do a lot of data loads in the background, back-end processing. You can do event-driven processing. We see a lot of customers using it for public API endpoints and web apps. Web apps are probably some of the biggest use cases I see because it's the easiest buy-in to get into container apps. I've got a web app with a custom domain and I need to get it scaled out. We usually go Azure Container Apps versus an Azure web app because it's all self-healing and self-managed. We see a lot of customers that are looking to use microservices, and there's a huge push using microservices and Dapper. Dapper is really cool. We have some, if you want to learn more about Dapper and how it works, it helps a lot of this triggering of scalability and everything else for your microservices. And it's pretty cool. So we've done a lot of work in this area to make this a more managed service. So there's less overhead and the apps are the first with your organization. So we're going to focus on AKS today, but I wanted to show you all this, just a nice comparison of AKS versus Azure Container Apps, because anytime we embrace the cloud, like Azure Container Apps do not work for every person. AKS does not work for every use case. You need to find the right thing that fits best for your organization. So to have more of that hands-on approach, more of that pliability, if you will, AKS is really good. It has a lot of flexibility and it's an infrastructure focus. Whereas Azure Container Apps, you start focusing more away into the application stack, and you don't have to worry about a lot of that. So there are things that are built in and supported into Azure Container Apps. So you have Envoy, Kata, and Dapper, which is pretty cool. So they're all built in. While AKS supports it, they're all built into Azure Container Apps. So there's going to be a lot more use case for Azure Container Apps. I would say more so than an Azure web app, but there's definitely a use case. So this is just a little good piece of information to show you what may or may not be the best thing for you. And I believe it's demo time. All right. So enough of hearing me talk. We're going to listen to Josh and we're going to do some code. And hopefully everyone's ready to get started, do some cool stuff.
And April, we did have one question in the chat, which is, what is the difference between Azure Service Fabric and Azure Container Apps? Does it sit somewhere in between AKS and Container Apps?
So Service Fabric was almost an alternative to AKS in the early days in Azure, and AKS was then built on top of Service Fabric at one point. I haven't spoken to the engineering team to confirm that, but Service Fabric was used in a lot of use cases where people needed that ability to containerize things and have that really hands-on approach, especially if something was more of a Windows OS focused and they just couldn't get it to work with AKS. And this is really early days. I'm talking probably 5 years ago. I talked about Service Fabric a lot. I'll be really honest. I haven't touched Service Fabric in probably 4.5 years. It was pretty unreliable as a service. It was great for abstracting workloads and microservices, but we've really moved past that a lot. And I think there are still customers using it. I just haven't actually worked with it in 4.5 years. So I struggle to really compare it. It's not even part of my conversation most of the time anymore.
Okay. So I think we're good to do some screen sharing.
Yep. Oh, there's one other question about container apps having a limitation on a /23 subnet. Yes, when a Azure Container App is attached to a subnet, it's got a limitation on the networking component. Mohammed, the product group has a public roadmap. Have a look at that and see if it's in there. If it's not, you can also submit an issue and a suggestion. It is a little bit limited at the moment, yes, because it's yes. So I think there is a plan to do it, but they will have that on their public roadmap available. And you can also open up as an issue. And if you work for a pretty good sized customer as well, speak to your account team and they can also get in touch with the product group on that.
Okay. So folks should now see my screen. April, please keep me honest with respect to font size. I know it needs to be larger.
A little bit bigger. I'm getting old. Make it a little bit bigger, please. I'm getting older. Sorry, not old.
All right, that's pretty big.
Yeah.
Hopefully that's enough for folks. All right, so we're going to make a directory. And we're going to call this AKS demo. And I'm going to add 1, 2, 3. You don't need to do this. It's just to make sure that it doesn't collide with any leftovers I may have had while I was writing the workshop. So the first thing we're going to do is we're going to run the Pulumi new command. This is how you initialize a Pulumi program. And so when you run Pulumi new, you're going to see we have like 206 starting templates at right now. So I'm going to filter that down. We're going to go Kubernetes Azure. And unfortunately, my gigantic my gigantic font size seems to have confused things. All right, so let's just do it right. So it's Kubernetes Azure type. So what this is going to do is this is going to use our Kubernetes Azure TypeScript template, and then you can fill in. We're going to fill in some configuration values that will help initialize the program. So we have a project name. We're going to use, that's fine. The default description default, that's fine. Stack name dev is the default, that's fine. We're going to use Kubernetes 1.26.3, which I believe is the latest supported version. Then it's going to ask us for an object ID in Azure Active Directory to make cluster admins. I'm going to use a specific GUID from our org. And so then it's going to ask you about the VM size that you would like for the worker nodes. Again, the default here is fine. Yes, we'll start with 3 worker nodes. That's good. Prefix for DNS. Again, the default, that's fine. And an SSH key that I will need to grab. And command written down. Nope, I know. SSH. All I'm doing is copying my SSH public key to the clipboard. In case anyone's wondering what I'm doing in that tiny little font. There it is. Okay, and we're going to create this in WestUS 2, which is close enough for me. Okay, so what's going on now? Well, if you've used Node before, this will look pretty familiar. It's doing an npm install. So it's going to install the Azure native provider, which is our recommended provider. That's the one that will give you 0-day support for all Azure features. And it's also going to install, no, it's not going to install the Kubernetes provider. We will be adding that later. So it's doing its thing, and I believe in you, npm, and I trust that you are going to finish in just any second now. In the meanwhile,
would you like me to get some elevator hold music for you?
Yeah, that'd be great.
So while Josh is doing this, I'm spinning up the workshop in a GitHub code space. Do you want me to go ahead and show that while you're
go right ahead.
Struggle busing? Let me just pull this up. So for those of you following along at home, I hope you can see my screen, by the way. Yes, no. Can you see it, Josh?
Yes, I can.
Okay, cool. For those of you following along at home, there is in the handouts, you'll see the GitHub repo. I have forked it to my repository so I can work on the code. So while Josh was getting everything installed, now you can see how long it's taking us to get started. It's not forever, but sometimes when you're starting a project, it can get really frustrating because you need all these extensions. I would normally go down to local, clone my code in VS Code and start working away. I have started using GitHub code spaces entirely. So if you guys are watching, you can see that Josh is on a Mac. I'm working on a PC. We're going to work on the same code. Now we can do that in VS Code, but if I use a GitHub code space, it is irrelevant which machine I'm on. And if the compute power in my machine is lacking, which often happens to us, or really locked down, I can run a code space. Now, I actually did this in real life a couple weeks ago. My laptop didn't want to work. I grabbed someone else's Mac and did my whole demo, and wrote code and deployed a website, all these things end to end in GitHub using code spaces. So if I click on the code spaces tab here, I've actually opened this and I just hit create a new code space. We can see that we can do all sorts of things with it. We can do pre-builds. We can share the link. but I'm effectively running Josh's code here in this code space. It looks just like Visual Studio Code. You get the same exact experience, and then some. So all your extensions load in. Josh could send me a live share link while he's working from VS Code, and I could see his code on my screen, and we could pair program and rubber duck together and do this together effectively. But this is running in a containerized environment on Azure. It's a GitHub product, but it's completely secured out. Now, the other thing you can do with a code space is you can build out what they call a dev container, which is a containerized environment. And then when you spin up a code space, all these things that Josh is installing are ready to go. So we don't have to wait to get everything pre-configured. So getting started on a project is literally the 10, 20 seconds it took me to spin up this code space. So I can see all of Josh's code. I can get started. I can open up a terminal window. And so while Josh is doing his thing on his side, I'm literally going to be working from a code space, and I'm going to deploy everything into Azure at the same time, just to have the experience. You ready to have your screen back?
Yes, I think it actually did finish a while ago, and the font size is messing up the rendering in iTerm. So, yeah.
Should use a code space.
Yeah. Okay, so here we are. We're back in Terminal Town. You can see that npm install has run. So I'm going to fire Visual Studio Code in this directory. And we're going to take a quick tour as I make my font size larger. Okay, we're going to take a little quick tour as to what Pulumi new generated. So we have a node modules. That's nothing particularly interesting. If you've used Node before, you know what's there. Those are your dependencies. We have a git ignore file, and then we have our index.ts. And so this is, and I'll take you through this pretty much line by line in just a moment. This is the entry point to our Pulumi program. This is where we define our resources, and this is where the action happens. The other thing that's worth checking out is your Pulumi. So this is pulumi.dev.yaml. This is the stack configuration file. So if you'll remember, when I ran Pulumi new, it was prompting me to enter all these values. And so you might be wondering, well, where do those values go? They go in the stack configuration. So if you wanted to create a QA or prod stack, you can keep those configuration values separate. Again, like we could change our dev stack, for example, to have one worker node, and then we could initialize other stacks and configure them to have more worker nodes. Or we could deploy our stack in a different location. And so one of the things to know about Pulumi is when it creates your resources, you can either specify you can either skip the name and Pulumi will auto name your resources, or you can specify an explicit name. Most of the time, you want to use the auto naming feature, and that will allow you to deploy the same stack in the same location, so that you don't have naming collisions. So going through this, this index.ts file. At the top, we have our import directives. That's pretty standard. You can see that we're pulling in certain namespaces from the Azure native provider. This code right here, I'm not going to go into it in deep detail, but this is essentially pulling those config values from our configuration file here. So moving along, so here's our first resource. We're creating a resource group. You can also grab an existing resource group. That's possible. We create a virtual network and 3 subnets. And you can see here, by the way, this pattern that I talked about earlier, where we have the output of one resource becoming the input of another resource. So we have our resource group resource here, and then we have our name, which is an output, and that becomes the input on our virtual network. So after we create our virtual network, we create our subnets. Again, we're using our virtual network name output as an input to the subnet. And then finally, we are creating our managed Kubernetes cluster, our AKS cluster. This cluster is configured by default to use a Azure Active Directory for authentication. And so we're not using any add-on profiles, although all of those are available there. We have our agent pool, and we're running on Linux, and we have set up our network profile. The next thing that we do is we grab our container services credentials. We do a little bit of transformation on it in order to get the kube config. And then at the bottom, we use these export directives to create stack exports or stack outputs. Stack outputs in Pulumi serve two purposes. First, it allows you to access values from inside that are inside a Pulumi program from the command line. So what I'll be demoing shortly is I will grab that kube config and use it to spit out a kube config file and then run a kubectl command. In addition, you can also get values via stack exports. You can use values from one Pulumi stack in another Pulumi stack. So in a more production-like scenario, you might have a network team that defines your networks. And so you would use you would set your some of your networking stuff as outputs in a networking stack. And then a platform team might use those network outputs as inputs to deploy, say, Kubernetes clusters into those networks. So I can now run the Pulumi up command. And this Pulumi up is the short for update. It is what will apply your Pulumi programs changes. So the first thing Pulumi up is going to do is it's going to give us a preview of what it intends to do. Okay, so what do we see here? So this is Pulumi telling us what it is going to do if we choose yes to this prompt. It's going to create a stack because this is the first time that we have run this Pulumi program. It's going to create our resource group, our virtual network, our subnets, and our managed cluster. So that's all the resources that we defined. In addition, it's telling us, hey, I'm also going to create these outputs. And I don't know what they are yet, but I know what type they're going to be. So let's say yes to this. And so it's going to start doing its thing. It's going to create the resource group. It's going to create the virtual network, which takes a few seconds. It's going to create the subnets. And then eventually it's going to start creating the AKS cluster. Okay, now this takes about 3.5 minutes, and I don't want to make you sit through that. So just bear with me as I find. So this right here is from 3 minutes in the future. And here we have our everything spun up. So what I'm going to do here is just to demonstrate that we have working infrastructure is I'm going to run Pulumi. Just going to copy the command. So I'm going to take that kube config and stick it in a file. And again, the way that you access Pulumi stack outputs is by the Pulumi stack output command. I have marked it as a secret. And so what that's going to do is this will put this into a kubeconfig.yaml file. See here, there it is, and it has stuff in it, but because it has secrets, I'm not going to show you the exact content. And now we can run a kubectl command using that kubeconfig. We're just going to list the pods. And what this is going to show us is all the stuff that AKS is running behind the scenes to make running your Kubernetes cluster easier. So this is all stuff that's running in the kube system namespace. This is not stuff you would normally interact with, but we can see that we have an up and running AKS cluster. So now that we have a cluster working, what are we going to do with it? Well, let's deploy a workload. Okay, and so how are we going to do that? Well, the first thing we need to do is we need to, pardon my scrolling, I'm going to clear the screen here. We need to install the Pulumi Kubernetes provider, which might already be installed, but the command would be npm I at Pulumi/Kubernetes. So yes, it has already been installed, but if you're running this on your own, npm is going to do its thing for a minute, and now we have Kubernetes available. So we are going to, so you'll need to add this import directive, which I already have here, which will bring in the Kubernetes provider and give you access to all of the resources within the Kubernetes provider. So going back down to the bottom of our program, we are going to create a Kubernetes provider. So if you have an existing cluster, you don't normally need to declare a provider explicitly. But because we created our AKS cluster in the same program that we are deploying our what we're going to be deploying our Helm chart, we do need to do that because the kube config from the AKS cluster is going to help us is going to inform the provider how to connect to the cluster. So we're going to new Kate's provider. We're going to call this Kate's provider. That's the name of the resource. And then we're going to say kube config. Notice, by the way, that we get very handy autocomplete here. This is one of the advantages of using Pulumi is that IntelliSense works just like you would expect with any other library that you're using for your programming language of choice. So we set that kube config to be our kube config output. And we save, and so that will create the provider. And then next thing, I'm going to get a little spicy. I'm going to turn GitHub Copilot on. And
you're just going to get fancy now.
Yeah. Let's see. So GitHub Copilot, by the way, April, if you want to say a little bit about it.
Yeah, I'll talk about Copilot. So GitHub Copilot, I like to call it my AI pair programmer. So when I'm writing code and I need help with anything, I have to context switch, right? I have to stop what I'm doing, use the magical search engine, and find an answer. Copilot will make suggestions for you. It will help. We just released a new feature, a lot of new features with Copilot called Copilot X. So you can actually chat to Copilot to do things. It can help with your PRs, help with your comments, and help you write a test in your code. Copilot, I call it my pair programmer. So instead of having to go use my favorite search engine, switch my context around in the middle of what I'm doing, and traditionally, also maybe phone a friend, right? Use a rubber duck, pair program with something. I can use Copilot to help me with that. It's also really good in a few other ways. So I live in the UK, but I'm an American by birth. So we spell things differently in the US versus the UK. And I was working with a guy who spent like 4 hours writing his infrastructure as code and put the letter S in instead of a Z for whatever he was doing. And it took him like 4 hours to find it. And it was a little bit of a language barrier, right? So it's things like that. And I think there's a lot of people here today that are English is not their first language, right? But you're writing code in English. So it's also great, helps lower that barrier to entry as well. And it's a really good tool to help us write better code. It's not always 100%, but it's really good. So I use it a lot writing PowerShell or any kind of infrastructure as code language to help me suggest things, to help me write better code. And I think, Josh, you're going to turn it on and start making some magic happen.
Yeah. So one of the ways that you can get Copilot to do stuff for you is by writing a comment. So we're going to deploy the latest version of the Bitnami Word Helm chart. All right. Well, it's off to a rousing start because that's correct. Next line. Chart. That's correct. That's correct. That's correct. That's correct. And I do not need a namespace, but I appreciate the hint. And then, oh, wow. Great job. Everybody, give a hand for GitHub Copilot. Nailed it on the first try. So you'll notice what we're doing here is we are using the kates.helm.v3.chart resource. There's actually two ways to deploy Helm charts. The way that I'm doing it here is going to run Helm locally, and it's going to break out this chart into individual manifests, and then you're going to see that in the preview. So let's clear the screen.
So how long would it have taken you to write that before, Josh, without Copilot?
All right. So if I did not know anything about the Kates provider, I would be going to the Pulumi. I'd be going to the Pulumi registry. I would be asking it. I'd be looking around probably for a tutorial and using Helm charts. You can definitely search within the registry for that resource, but like you'd be looking up the examples. I would definitely not have known like, oh, I have to fetch it from because I'm not super experienced with Helm. I would have forgotten, oh, it's not in the default Helm charts repo. So significantly longer. I'd say factor of 10, since that was all of, 30 seconds to
Mhm.
get those magical few lines of code. Okay, so we're going to run Pulumi up. And Pulumi is going to let us know what it's about to do. And behind the scenes, so you can see that it's going to create the provider, right? Because we just created that. And then because we're using the Helm v3 chart resource, it's going to break down our chart into actual each single manifest in there. If we use the release resource, we would only see the Helm chart itself. I personally prefer the chart resource because it's a little bit easier to tell you like what is actually in that Helm chart. So yes, we want to perform this update.
Yes.
It's going to do its thing. This is going to take about 3 minutes. So at this point, it might be a good time to show you what the Pulumi Cloud does. You see this link right here, View in Browser? I'm going to click that. Or actually, I'm going to copy the link, and then I'm going to bring over my browser, and we're going to paste that. And so you'll know the first thing you'll notice is that all the output, and I will make this larger, all the output from the Pulumi CLI is available in the Pulumi Cloud backend. We can look over our chart, or excuse me, our Pulumi stack here, and we can get a full activity log. So you can see all of the things that we've done to this stack. In each update, you can see the resources that were added and removed. So we can click into the details here. This is when I ran this a little bit, when we ran this earlier, when we created the managed cluster. You can see how long it took to run. We can go into, so getting that activity feed, that's really helpful, right? Because you can see who changed what and when, which is really, really important when you're tracking changes to production infrastructure. In addition, we can go to the resources tab, and we get a handy list of all the resources that are in our stack. And for many of these resources, you will see a link that will take you to the Azure portal. Oops, sorry, that is actually trying to take us to our Kubernetes portal, to the Kubernetes UI. But if I click this manage cluster link, that will open it in the Azure portal. So we can get a nice direct link to our cloud provider's console, and then see the details of any infrastructure we've created. So that's like super helpful. Another fairly new feature is we have this resource search. And so what this allows you to do is see all the resources in your organization and search for them. So if we do Kubernetes, we can see that we have all of our Kubernetes resources here. There's a lot more you can do with this. We will have an upcoming workshop actually on some of these features that we call Pulumi Insights. So please, after this workshop is concluded, we'll take you to a landing page where you can sign up for our newsletter, and that will let you know all of our upcoming workshops. And again, among them will be a workshop on Pulumi Insights. So that is a brief tour of Pulumi Cloud. I definitely encourage folks to check it out. But let's get back to our demo code. Aha.
I have two questions for you. Actually,
Sure.
one question for me I'm going to answer, and then one for you, Josh. So Roderick asked about proprietary information. So his company is shy of using Copilot and Chat GPT because I think the employees will give away, their concern is employees will give away proprietary information. So these AI systems are built on publicly available code. So you can leverage this code in Copilot. So you can leverage the publicly available code effectively that builds the machine, right? The more we feed the machine, the more it gives back to us. That's why I could write really good Pulumi code a few minutes ago. But if you're working in a private repository, it does not share that. So if you're working in a private GitHub repository with your company's code, it doesn't pull that code out. If you're in a publicly facing repository, yes, that is searchable. In terms of Chat GPT, it uses the same mechanism as well. So they are using publicly available things. So I guess if you're working in private repos, you should be okay. Now, in terms of access to those repos, there's a whole other slew of discussion around, not putting passwords in your code, securing things, MFA, doing all the things you should be doing for authentication and protecting your code and your team. Question for you from ManMeat: do Pulumi track the drift insight? I'm gonna say it looks like differential for an AKS.
Yeah. So if we took our configuration, right, and we change this to be, we want 5 worker nodes instead of 3. And then I run Pulumi up. Pulumi is going to show us the right. So you see here, we can actually see the details. That in our managed cluster, it's going to update the cluster. If we look at the details, that it's going to change our agent pool from 3 to 5. So we didn't have to explicitly say add 2 worker nodes to our cluster. We just say what our desired end state is, and Pulumi will figure out the steps to make it happen. So hopefully that answers your question. So I'm actually going to skip this update. So the next thing I'm going to do, is I actually need to add some stack outputs real quick. I'm going to just copy these. So this is going to give us the load balancer IP of the WordPress chart that we just deployed right here. And so I'm also going to change this back to be 3 because I don't want to update the cluster because that's probably going to take a while. Clear the screen, and then I'm going to run Pulumi up again. Pulumi up, by the way, does have a -y flag that will skip the preview and just do it. That's fine if you're learning. Please, please, please do not do that on your production infrastructure because that's not safe. But when you're learning, the -y flag is pretty useful. So we're going to run a preview. Okay, it looks like our secrets are going to change for this. I'm not exactly sure why. It might. Maybe the Helm chart generates a password behind the scenes. But in any case, we're going to get our front-end IP, which is what we really need here. Okay, cool. So we can now run Pulumi stack output front end IP. Oops, mistyped that. Oh, I might not have saved it before I ran Pulumi up.
Let me know when you're ready for your next question, Josh.
Sure, I can take a question now.
Sure. Mark's asked a question. Mark, I did see your question in Q&A and in the chat. It's a matter of interrupting Josh and his flow. So sorry, Josh, not really. Sorry, not sorry. Mark has asked, can we inject normal code into a Pulumi project? I.e., I use C# and when I create my cluster, I need to set up an entry in my host file before I can connect using kubectl because it's in a private cluster, needs VPN access with no DNS resolution. Can I inject normal C# code to handle this, or is there a provider for doing this kind of thing?
Okay, so that is a detailed question. I can tell you that in general, right, you can mix and match regular code with your infrastructure code. That's one of the reasons to use Pulumi in the first place. So if you need to set up an entry in your host file before you can connect, right. So what you can do is, so Pulumi has a command provider, and that's in our registry. And so the command provider is kind of sort of like a catch-all. So if you want to call any external program, you can do that using the command provider, and that will usually get you what you need. You can also create your own, I believe it's called a dynamic provider that will allow you to essentially do execute arbitrary code as if it was a resource. And I do not know, because the demo gods loathe me, why we are not.
It's because I'm here. I'm the curse. It's fine.
Yeah, I'm gonna cut this out real quick and just wonder if I'm not in the directory that I think I am. No, I seem to be. Well, the good news is let's just see if we can get that output to appear. If not, I have a separate stack that I've wisely.
that you called through. Manmeet has a question I'll answer while you are fixing that. Manmeet asked a question of what if something is changed on Azure, the portal, or within AKS manually? When we do a Pulumi refresh, will it update the stack state? Sorry. So no, Manmeet, if something's changed on your AKS clusters or on the Azure portal, someone's like manually changed something. When you do a Pulumi refresh, it will update the stack state. You'll want to repush your code to get it back to the originating state. So state management effectively is what you're looking to do. I think his question was around reverting changes, but yeah, it will revert down to the version you have. The other thing is, this is where we want to think about limiting user access to the portal and to do the jiggery pokery. So this is where working out of like a pipeline, like a CI/CD mechanism, is really beneficial, because you can prevent people from making those changes manually. But I think, yeah, he was asking about the version changing, like someone manually does a change to your.
Yeah. So if you change something in the console and then run Pulumi refresh, it will do the drift detection, and it will, if you run Pulumi update, will return it to whatever it is in your Pulumi program. So when you're and most IAC tools, all of them, as far as I know, function the same way with that drift detection. That when you use an IAC tool, your IAC tool from that point forward is designed to be the source of truth. Okay, so I am having a little trouble here. So I'm going to just switch over to backup stack. And we do have the front end IP here working. And I'm going to bring this into the browser, which I'll bring that over here. And we'll enter that. Oops, no, sorry, not HTTPS. Regular old HTTP. And we can see that we have WordPress installed and working. And so that is the end of the demo.
And it worked.
And it did work.
I can share some cool stuff with Azure Container Registry while we're there.
Please do.
Yeah. Let me pull up my. Okay. Let me go ahead and screen share some stuff.
And also, sorry, if folks have any additional questions, just ask in the chat with the Q&A tab. Now that I am not demoing, I can devote my full attention to answering.
All right. So just want to go a little bit further into AKS. So I keep all my images in Azure Container Registry that I utilize. So you can use things like Docker, etc. I manage them from here. The other advantage of doing this from here is that I can connect this into different security tooling. And the reason why I'm going to talk about security tooling is when we deploy stuff, how do we manage it, maintain it? So we did have questions about, drifting our state, but we have to talk about security, right? I think it's probably just one of those things that we talk about. So I'm running Azure Container Registry here. My images are sitting in here. I can do a lot of tasks. I can get insight into all the registries I'm working and any other repos, etc. The other thing I can look at here that is really good is looking at what's Microsoft Defender for Cloud. We usually talk to people about using this heavily. So when you're deploying something, so Josh has deployed everything today from his local, what does Mac call it? The command prompt. Help me out. Yeah, command prompt. Okay. Usually I'm doing deployments through pipelines. So whether it's Azure DevOps, GitHub Actions, etc., I'm hooking in a registry scan for every image that I'm deploying to my containers. And this is effectively the output of what it has. So it's found some issues in my images that I'm using, so I can stop the deployment. So not only am I managing the infrastructure that I'm building, but I'm also managing what actually is getting deployed. So in this very good use case, I specifically have about 52 images that I'm I'm utilizing, and we can see the security updates that are an issue. I can go into it, see it. I can see what the vulnerabilities are, and then how to remediate it. So it's not just deploying AKS, but then how to manage that environment, right? Because we still have our images on the back end. Now, this is really cool. Now, Josh was showing, he talked about other cloud providers, which is absolutely a valid point. I'm going to pull up Microsoft Defender for Cloud. You can see all your cloud registries. So even though my images that I'm deploying into AKS are sitting in Azure Container Registry, I can see my security posture across all the clouds. So I can see what my Azure security posture looks like, AWS, GCP, and actually just get that full insight. I can also look at regulatory compliance. I actually sat with a customer this morning, and they were specifically asking about regulatory compliance. And what's interesting about regulatory compliance and infrastructure as code is we have these legacy ways of doing things. So when I was speaking to them about their compliance, they're like, yeah, it takes us a while to get an actual deployment for our infrastructure as code because we have to have a manual check. And it's not part of an actual regulatory compliance. It's just an old legacy thing that's been in the FIS industry and in the government industry for where they are that just has kind of stuck around. So we talked about other ways to get around that. So they can still do their infrastructure as code. They can still run their tests. They can still get into Azure. But before they go to production, they're using a manual check in their pipeline. So, but they can go ahead and look at the Defender piece here and say, right, everything ticks all the boxes. We've hit all the regulatory compliance. And in a better situation, all their container registry images are healthy. And they can report that back to the organizations and stuff. So this is just a nice little add-in that you can add in when you're using AKS or any kind of container images to help increase the security. So I have this all hooked into the pipelines I run to deploy all this stuff. And it adds in as a task effectively. So when I go to deploy my infrastructure in my pipeline, I add this task in and it runs a check. And if it fails, my images fail, i.e. like I had those vulnerabilities, it doesn't go. And it doesn't update that image. So that's also another way I help protect that state that's in my clusters and everything else as well with the OS images. Right. Open up for questions. Are there more questions out there in the world of
questions? Any questions on,
questions on everything. See Mark's question. We've answered that. So anyone else? So a lot of chat about in the comments about Pulumi AI. Again, using that hand in hand with Pulumi AI, Copilot, give it a shot. It is literally a way to leverage learning. It's hard, I think, as a net new, not knowing anything sometimes. For those of you that haven't used Pulumi, a really fun thing to do is go to ChatGPT and ask it to spit out a brand net new script for you. And actually you can do it with the Pulumi AI as well, can't you, Josh?
Yeah. I was about to share it.
I'm going to do that too. I'm going to go into ChatGPT while you're doing the Pulumi AI.
Cool. And of course, Pulumi AI is based on ChatGPT.
And it's free.
Let me shuffle some windows.
If it's free, it's for me, as we used to say.
Yes. So here's Pulumi AI. So I don't know. Let's ask it a question. So we had a question from Mohammed who said, "Do you have an example with custom DNS zone?" I assume that is an AKS cluster with a custom DNS zone. If you could confirm that in the chat, that would be great. Let me see. Scroll down. So I am not familiar with every AKS feature, but let's just see. Show me how to create an AKS cluster that uses a custom DNS zone using the Azure native provider. Let's see how it does. And by the way, you'll notice that we have a language selector here that will give you code in any of the languages that Pulumi supports. So it's going to do its thing. One of the things that I learned actually using Pulumi AI, and I'm certainly no expert on large language models or generative AI, but apparently this preamble that it always gives you actually helps it write better code. I always kind of wondered about that. I was like, why do you always just basically give my question back to me? I actually told it to skip it because I told it to skip the preamble because I was very busy one time. But no, apparently it is much better to let it do its thing.
Yeah, the other thing I found too is it's very literal when you're asking to do things. So actually ChatGPT is down at the moment saying their systems are busy, ironically. So that's cool.
Yeah, I get
Josh
that a
is eating
lot.
all the bandwidth. Yeah, so use the Pulumi AI because there's higher availability. It's very literal in what you ask it to do. So anytime I'm writing any kind of new type of code or anything else, be very literal in what you ask it. When you use ChatGPT, it also explains to you why it came to that answer. Or how it came to that answer. Like it kind of works it through. So I find that really useful for any new language now or any problem. It talks me through it. So I kind of understand not just an answer, but like its process to understand and get to that point.
And this code that it's generating certainly looks plausible. I couldn't tell you whether it was exactly correct.
Yeah. So a
But
fun
it's
thing to do is export it, take the code, and go run it and see how it does.
yeah.
I wrote a blog about this, not with Pulumi. I was using PowerShell. I think I wrote it like 2 months ago. And I literally had ChatGPT write me some PowerShell, spat it out, and I went to deploy it. I went to deploy it with GitHub Actions. So I just had to create a task to pull some content out of Azure. I wanted to know like what resources I had, etc. Um, and then I also went to do it as an automated task using an Azure function. And both had pros and cons. So
Yeah, so this code, it may not be 100% correct, but it will certainly give you, a very, very good starting point. Yeah, so that's Pulumi AI. We could even do another Pulumi AI example. Show me how to deploy Nginx on Azure Container Apps using the Azure native provider. And of course, it's going to give us the preamble, as it always does. And by the way, folks, if you have any more questions, please, by all means, let us know in the Q&A tab.
So I saw that David Riley was Rowley. I can't say his last name. Rowley was in the conversation earlier. He literally lives behind me, like a mile behind me, but he could probably like throw a rock and hit my office.
Very cool.
Yeah.
Yeah, so you can see that Pulumi AI will, it's we are using it internally, by the way, extensively. It is a great way because I mean, again, there are just so many providers and so many resources that like it's impossible to cover every single use case. And Pulumi AI is like just has been so helpful at like, getting like a really excellent starting point for your Pulumi programs.
And I actually had I was involved in a conversation recently about a team that their whole task as the infrastructure team was to build the infrastructure as code for the developers. So the developers would request an Azure resource and like literally anything, AKS, app service, whatever, video indexer. And the job of this infrastructure team was to write the infrastructure as code for it. And they struggled because they didn't know always the Azure tech. And they never went back to the development team to ask why they needed such and such thing. They just did it. So it was interesting how that team worked. And we like dug into that. But this is a great use case to say, right, they need to deploy a resource. We haven't done it before. Boom, go and do it.
Cool. We have a question. Can we do a more advanced workshop on Pulumi features? The answer to that is yes. Please join the Pulumi community Slack and leave some feedback there about what types of things you'd like to see. And also, once we have concluded this workshop, you'll be taken to a landing page. You can sign up for a newsletter there. And if you do that, you'll be informed of all of our upcoming workshops. So,
ooh, ChatGPT just came online for me.
Oh, very good. Yeah, if you want to take over the screen, by all means. By the way, one of the things that that Pulumi AI really helps with are the properties of container apps, whether you're defining like Kubernetes manifests or container apps. Some of those options can get pretty nested and pretty deep, and there's a lot of them. And so Pulumi AI is super helpful for like navigating that. So we have a question. Does Pulumi AI have the same 2021 knowledge base limit as ChatGPT? So we are, all right, I am not 100% sure on this. I believe ChatGPT 3 is the 2021 data set. And please, anyone, if anything I'm saying is wrong, please correct me in the chat and I'll make a correction. And Pulumi AI has an option to use ChatGPT 4. And so I believe that has a more recently trained data set. I can test this offline because but I need to remember what the use case was. There was a use case where I was using an earlier version of Pulumi AI, and it did not know of the existence of like a new major version of a provider.
By the way, I also am really nice to ChatGPT. I say good afternoon or whatever, and I ask it very nicely, and I find it's very nice back. I think it's a weird little thing, but it's like a human, right? Yeah. So yeah, so you can see that ChatGPT's come back to me and like, yep, what kind of resources and do you have existing code? And you can integrate that on all at once. So it's pretty smart. It's pretty nice. Is there any significant difference between Pulumi and AI and ChatGPT except for the language selector buttons? So in ChatGPT, I have to tell it what language I want it in, whereas Pulumi AI just select it. In terms of that, they are using the same backend for the most part. So,
And the Pulumi AI code is open source.
Yeah.
I'm going to.
So the best difference with the Pulumi AI code is that folks are contributing directly to that, where ChatGPT is using a different knowledge base.
But that's a great question. I have found that in the anecdotal sense, it definitely gives like, you have to enter a lot less in the actual prompt, and that it tends to give, I think, a little bit better code than just regular old ChatGPT. You also don't get rate limited on Pulumi AI. I mean, unless you go bananas on it. And I have found that lack of available, like the ChatGPT is often like overloaded and not available.
Yes.
So that's another reason that I've grown to prefer Pulumi AI.
Yeah, I hit refresh a lot. I'm not gonna lie.
Yeah.
So yeah, so I'm generating all the scripts we need here. But yeah, it's great to just go ahead and run, see how it works. I did this in Golang because that's my preferred language. But yeah, thank you everyone for joining. If there's no further questions, we might have to maybe end it. Let everyone go get lunch or dinner, depending where they're joining from, or breakfast even.
Yeah. Let's give it a few, like another minute or so. But if folks don't have any additional questions.
What is your favorite food, Josh?
Oh, my favorite? Oh man, hard to choose. I have gone through many different cuisine phases in my life. The first time I discovered Indian food, I was eating it almost constantly. I was in college. Once I was out of school, I really got into Sichuan cuisine. And lately, I've kind of been on a Japanese kick. There's a really, really excellent izakaya, which is basically Japanese tapas, in Philadelphia that I've been enjoying. I also went on a trip to Spain recently, and the top. I didn't even eat paella. I was in Spain for over a week, and I didn't have paella once, but I did have this amazing salted cod. It's called bacalao. It's the same thing in Italian, bacalao. And it was like the best. It was kind of tastes like the best lox I've ever had in my life.
That's awesome. Yeah, that is awesome. Yeah, I love Spain. Love Spain. Good food. Yeah, I think traveling helps expand your breadth of food choices.
Yeah. Oh, so we do have one more question. I want to integrate with Octopus Deploy for installing the infrastructure. Do we have a feature to destroy the infrastructure after using it? Yes, and I will gladly share my screen because this is the thing I always forget to do, and I'm always worried that folks who are following along are going to forget to destroy their infrastructure. All right, let me get back to Visual Studio Code. And the magic command to do this, I'll clear, so it's Pulumi destroy. When you run this command, all the resources will be shown as deletes. And then you say if you want to perform this destroy, you can choose yes. And it will do its thing. And that will take about About 3-5 minutes to fully run.
And you can just throw that down in your pipeline for Octopus deploy.
Yes.
The other thing you can do, again, Azure DevOps, any of the CI/CD tooling. I have a task, or sorry, not a task, sorry, a GitHub Actions workflow in my repository. So I spin up like dev test environments before things go to production, like maybe a dev environment. When I close my pull request for every code submission for changing my infrastructure's code, it pulls down that dev environment. So when I close the pull request, I get merged into my main branch. It destroys it automatically, and that's an that's a triggered one based off of any pull request closing with a certain tag on it, so that I don't have to remember to do that. So that's the benefit of having things kind of in automated triggers or CI/CD pipelines as well, especially using different environments and stacks.
And we do have a Pulumi provider for Azure DevOps, by the way. So if you want to define your pipelines using Pulumi, which by the way is a practice I strongly recommend, because pipelines, regardless of the cloud provider you're using, often take a long time to set up, especially around permissions, and being able to programmatically recreate them can be very, very helpful and a huge time saver. So some links to continue your journey. If you go to pulumi.com/Kubernetes, that'll give you all of the rad features of using Pulumi and Kubernetes. For more workshops, we have a static page well, it's not static. It lists all of our upcoming workshops, but you can also sign up for a newsletter and you will get notified of all upcoming workshops. If you go to pulumi.com/get started, that'll /docs/get started, that will give you some intro material if you're not yet familiar with Pulumi. Our examples repository has a ton of examples. It's just a GitHub repo. So if you search for the cloud provider or resource type that you're looking for, it should come up in the search results. And then if you want to see our complete list of providers, that is available in the Pulumi registry, which is available at pulumi.com/registry. So with that, I'd like to thank everybody for your attention. Please stay in touch.